Hello everybody, this is Mr. Coker and this is the homework 5.B.1.C. It's 6.16, 6.18, and 6.20 out of the Chang book. First of all, we have a problem where we have a gas that's expanding from 26.7 milliliters to 89.3 milliliters against various external pressures. So we want to find the delta V. The delta V is found by taking volume final minus volume initial. So that's 62.6 milliliters, which converts to 0.0626 liters. So our delta V is 0.0626 liters. So our formula is work equals negative P delta V. In a vacuum, pressure is 0 atmospheres. So letter A, work equals negative 0 times 0.0626 liters, or 0 liter atmospheres, which would be 0 joules. If the pressure, external pressure on the gas is 1.5 atmospheres, then work equals negative 1.5 atmospheres times 0.0626 liters, or negative 0.094 liter atmospheres. Multiplying by our conversion factor, which is 8.314 joules over 0.08206 liter atmospheres, we get negative 9.5 joules. Letter C, if the external pressure was greater, 2.8 atmospheres, now our work would be negative 2.8 atmospheres times 0.0626 liters, and negative 0.18 would be our liter atmospheres, and negative 18 joules would be our work. So in joules. 6.18, it said that positive 74 joules of work along with negative 26 joules of heat. That's because they said the gas was compressed, so that's positive work. Delta V is negative, so work equals positive. Q is the heat. It said it gave off heat, so that's negative 26 joules. So our formula is delta E equals Q plus W. Q is positive or negative 26. W is positive 74. So together they add up to positive 48 joules for the change in the internal energy. 6.20, they wanted to know what would be the work when a mole of water turns to a gas, a vapor, at 100 Celsius. So work equals negative P delta V. The pressure is 1 atmosphere in the problem. So we just need to find the change in volume. Change in volume should be the volume of the gas minus the volume of the liquid. They told us the volume of the liquid is negligible. It's about 18 milliliters. So we're not going to count the volume of the liquid, so we're just saying the change in volume is from 0 to volume of gas. It's volume of gas. So the volume of the gas can be found by the gas laws. PV equals nRT, so V equals nRT over P. We had 1 mole, we had 0.08206 for R. 100 Celsius is 373 Kelvin. The pressure is 1 atmosphere, so that's 30.6 liters. So now plugging that back in, we get work equals negative 1 atmosphere times 30.6 atmospheres, or I'm sorry, that should misprint. Should we say 30.6 liters? So then it comes out to negative 30.6 liter atmospheres. Multiplying by our conversion factor to joules, we get negative 3,100 joules, or negative 3.1 kilojoules. Thank you very much.